In this video, we're going to take a look at errors and exceptions. And honestly, when you first start programming, especially in Java or in Android, exceptions seem like kind of a pain in the rear. If you remember, we had this network DAO and Control M, and when we implemented this method here, we had to make a decision. We got a red line. I can simulate that red line one more time by taking this throws clause away. We got a red line right here. And the red line says unhandled exception type client protocol exception. So in that case, we adjusted the method signature to throw this exception. Now let's take a look at online plant DAO. In online plant DAO, we got a similar error when we invoked our network DAO. Once again, I can recreate that error if you're interested. I'm going to comment out this try catch block, highlight, and then control question mark, we'll do a block comment. You see, we have a bunch of red lines here. Unhandled exception type JSON exception, and then we have unhandled type exception IO exception. So how do we handle those red lines? It seems kind of inconsistent. In one case, we added the exception to the throws clause. In the other case, we did what's called catching the exception. And people who are generally a little bit newer to programming tend to get confused, and for good reason, and also tend to not always follow best practices. So what we're going to do in this lecture is we are going to take a look at exceptions, but we're going to look at exceptions and see that, as a matter of fact, they're not a pain in the rear, not at all. As a matter of fact, one moment as I recenter, as a matter of fact, exceptions deal directly with the three overall design principles of Android. Enchant me, simplify my life, and make me amazing. Okay, exceptions deal directly towards enchant me, simplify my life, and make me amazing, the three Android design principles. Additionally, you'll probably remember early on in this term, I spoke about the triangle, which is the traditional saying is functionality, time, and money, pick any two. I've changed this to Brandon's triangle, which is I combine time and money together. In some cases, those are interchangeable. Other cases, maybe not. Functionality and quality. So my triangle is quality, functionality, time, and money, pick any two. But one must be quality. And reason being, if you don't have quality, you will quickly earn a bad reputation on the Google Play Store through bad comments. And once you have them, you can't get rid of them. It's not easy. So you definitely want to focus on quality. And exception handling is one of the things that's going to help us focus on quality. So what are exceptions, and in general, what are errors that can occur when we're running a Java program, and in this case, an Android program? I'm going to go to ucjava.com. So I type ucjava in my URL, and then I hold Control and hit Enter, and it adds the .com. That's a domain name that I purchased, and it simply redirects to my UC homepage. So from my UC homepage, I'm going to scroll down and click on Computer Programming 2. This is a concept that we discuss in the introductory series. From there, I'm going to click Exceptions and Errors, and we're going to talk about three categories of errors. So first we have syntax errors. These are a lot of times what we get when we have red lines. That means there's an error in our grammar, or there's an error maybe we forgot a semicolon, something like that. That'll give us a red line and tell us, hey, there's a problem here. That's a lot nicer than the old days. Let's say maybe I forget a period here. That would be a syntax error as well, because it says I don't know who add_plants_add is. Now I do know who add_plants_add is. You know, I realize that that's a variable with a method. So syntax errors are a lot easier to detect than they used to be for one big reason, and that is that most development environments now will detect syntax errors and redline it because they automatically compile. Every time you type, every time you save, it does an incremental build, and what happens during an incremental build is it will tell you if there's a redline. And that's why I always say fix a redline immediately if you have one. If you see a redline, first thing you want to do is fix it. Okay, when I started teaching back in around 2000 2001, our IDEs did not do that. As a matter of fact, we had to manually tell them to compile. So we could type away all we wanted, and then when we were ready, we would compile. And one of the big lessons that I talked about back then, back in my first few years of teaching, was compile frequently. It wasn't compulsory. You could go all day long and not compile. I would have open lab time where people could meet me for help on the weekends usually. And a lot of times somebody would come to me with something that was absolutely sloppy. And my advice many times was start over because it's not fixable in its current state. To which a student would typically get very irritated and say, well, I spent 3 hours on this. And my response was, well, it would take about 6 hours to undo it or about 15 minutes to do it right the first time. And my next question was, when's the last time you compiled? And many times the answer I got in response is, oh, I haven't compiled in 3 days. I was afraid to because the last time I compiled, I got 100 errors. So that's something we just don't have to worry about as much anymore because compilation now is compulsory. It happens automatically and it tells us when there are errors. So the syntax errors are the easy ones to take care of. Runtime error. A runtime error means that while we're using our application, it suddenly and unexpectedly dies. That's going to lead to low ratings on the Play Store. That's one that we definitely want to avoid. That can be caused by threading issues. It can also be caused by uncut or mishandled exceptions. As a matter of fact, I'm going to try a little experiment. I'm going to load my Plant Places app. It's currently loading. And then I'm going to turn the wireless network off on my laptop where I'm recording this, and we'll see what happens to the current application when I don't have network access. We'll see how it deals with that situation. Okay. Finally, we have logic errors. These are difficult to find because honestly, nothing looks wrong. The user can use the application, the user can insert the data, but for some logic reason or maybe some computational reason, the data that we're giving to them or the data that we're getting out in the background is not what is expected. You can probably think of some examples with this with some apps that you may use where you put in data and you're not getting nearly what you're expecting. So our goal is to minimize all three of these errors. And one easy way to minimize runtime errors is to deal with exceptions properly. And so to do that, we need to know a little bit about what exceptions actually are. So exceptions allow us to work with problems that arise when the software runs. They allow you to save work in progress, notify the user, and perhaps give the user a second chance. Now this is important. When we encounter an exception, we will typically encounter one of two types of exceptions. A checked exception, which is something that might happen because of the work that we're doing. For example, when we're trying to access network data, we might not have a connection to the network. When we're trying to access the database, we might not have access to the database. So checked exceptions are something that's fairly unique to Java. You don't see these so much in the Microsoft programming languages. But checked exceptions mean you're doing something that is external to the application, and you need to think to yourself, what are you going to do if something goes wrong? Okay, you have to make a conscious decision. What are you going to do if something goes wrong? The reason why they're called checked exceptions is when we do this risky behavior, like calling a network, Java forces us to make a decision. They force us, as we just saw with those red lines, to decide what are we going to do. Are we going to throw the exception, or are we going to catch the exception? So which is best? Do you want to throw the exception? Do you want to catch the exception? Catch the exception means that you have some logic local to the method where the exception was thrown, and this logic will only be called if the exception happens. These catch blocks will only be called if the exceptions happen. That's what's called a catch block. The other option is to throw an exception, which means, well, there's nothing I can do about it, so I'm going to throw it back to the method that called me. I'm going to throw the exception. So which one is best? Well, it depends on the situation. the first question to ask, is there anything that you can do to heal this exception locally and not even bother the user? If so, by all means, do it. If so, that's our first order of business. For example, if I go to the online plant DAO, I have here what's called an IO exception, an input-output exception, and a client protocol exception. One of these may arise if we are unable to access the network to get network data. So think to yourself, what would be a good way to handle this? What would be a good way to fix this locally? Okay, if you can't get to the network, how can you still amaze, enchant, and simplify the user's life? How can you still do this? I'll show an example that I use quite a bit. I'm going to put in a bit of a plug for an app here, which is, I do travel a lot, and I usually assume if I'm out of the country, either I'm not going to have network access, or, let me see, 1 second here. Either I'm not going to have network access or it's going to be very expensive. And as I've traveled for vacation, one of the apps I really like are the TripAdvisor apps. And we'll say TripAdvisor, I'm going to say Edinburgh. As luck has it, I will be there over spring break this semester. So Edinburgh City Guide, it's free. I've used these apps in Paris and Amsterdam and gosh, where else? I know I've used them in a couple different places. I want to say London, but I don't think I have yet. But anyway, what's interesting about these is the app knows that I might not have network access. And so what this allows me to do is download the data locally. So that's something to consider for your application. If we have an exception that arises because we're trying to access something on the network, when we catch that exception, let's not ignore that. That's very important data. When we catch that exception, it means we're not able to be on the network. What do? Why don't we try to access a local copy of the data? If we can't access something on the network, let's toggle over and try to access data locally. Now, of course, there is a bit of a prerequisite there. We have to think about, well, we're going to need to have the data locally first, aren't we? Okay, we're going to need to have the data locally first. So we're also going to need to think about how we can have, and more importantly, maintain a local copy of data. Okay. Now, if you're in my Northwestern class, this is one of the last videos you'll see because our quarter is coming to a close. If you're in my UC class, we'll have a few more videos after this because we have several weeks left in the semester. But for my Northwestern friends, I will tell you, please do keep in touch. And if you watch my channel, you will see I'll have some videos that discuss exactly what I just mentioned, which is how to copy data locally, how to do that and how to reference it locally. So keep in touch, keep watching the videos even after the term's over, and hopefully that will be some benefit to you. So that's an example of healing. That's an example of how we can heal ourselves. Now, let's say that we don't have data locally. Let's say for some reason we have not obtained that data yet. Then what do? We've tried to get it over the network. Couldn't do that. We tried to get the data from a local data source. We couldn't do that. In this case, maybe it's time to give up. But here's the risk. If we just do a catch like this and we just have a simple stack trace printing, we're not informing the user. And what might happen is that our app might crash. And we'll get one of those errors that you see occasionally where it says, sorry, the application is, not an application not responding, but I forget the text right off my head, but I will offhand. But we'll generate one of those anyway, and I'll show you what it is. That is a runtime error. Okay, so what we want to do is we want to catch an exception in the case where we can heal it locally, but if there's nothing else we can do, we want to alert the user, and we don't want to give the user too much details. Keep in mind that users come in two flavors, people who don't know anything and people who know too much. We don't want to arm a hacker with too much information about our software. So what we will say, we'll show a message that says something like, sorry, we're unable to get to the data at this time. Please try again later. Some friendly user message. Okay. So 2 things we can do: catch and try to heal, or send a message to the user. Now, here's a question though. What if we are in a class that can't raise a toast? See, this is a network DAO. If I went in here and I said toast.makeText this, comma, sorry, unable to access network duration toast, whoops, toast.lengthLong .show. Okay, that's how we show a message, but we have a problem here. Toast.makeText won't work because when we pass in the current object, that object has to be an object that implements the context or extends the class called context. Network DAO does not extend anything. It's not a UI class. It cannot raise a toast. So what if we get an exception in a class where we're not in the UI and we can't physically raise a toast? What we need to do then is we need to tell the method that called us that we're raising an exception. We need to send a message back that tells the method that called us we're raising an exception. Okay? And then that method will make the same decision. If it is a UI method, it will raise the toast or raise some kind of message to the user. If not, it will throw that exception back. It's going to keep throwing exceptions back because eventually we're going to get to the point where we do hit a method in a UI class, in an activity, and then that can show a message to the user. Okay, so that's when we want to use a throws. We want to use a throws when we need to send information back. We need to send information back until it hits a UI layer. That's typically when we'll use a throws clause. Okay, another consideration. Let's say I don't have network access. This line number 36 right here is going to fail. If I don't have network access, line number 36 is going to fail. Now, line number 36 is the line that is getting back our data. If it throws an exception, we're unable to get back data. If we don't have any data, do we need to bother parsing the data? No, that'd be silly, right? Why would we want to parse data if we didn't get any data back? So we have to be very careful of where we put logic that is dependent on a method that might throw an exception. Okay? In other words, everything that follows line 36 all the way down to the catch block assumes that we were able to get data populated in this raw plant data variable. Everything I'm highlighting here assumes we have data to parse. Okay? The placement of that is very intentional, and here's why. If we don't have data, if something went wrong, it's going to jump all the way down to this catch block and skip everything in between. Okay? If we have a network exception, it's going to skip everything until it finds a matching catch block. Which means if you have anything that's dependent on an exception not being thrown, in other words, a normal course of business, put it between the method that might throw an exception and the catch block which will catch the exception. A common thing people will do is wrap this line only in a try-catch block. Wrap this line only in a try-catch block. And then take all of this data and move it after the catch. You don't want to do that. You don't want to do that because these lines are dependent on this variable being populated. And if that variable is not populated and it goes to a catch, and then you have logic here that's dependent on a valid and populated piece of data, it's just going to result in yet another exception, and that exception might well end up terminating your program. So that's a situation we do not want to be in. Now, this might not seem obvious right off the bat. It is something that requires a little bit of practice, but the rule is this. If a method can throw an exception, the exception when thrown will be caught by a matching catch block. If there are no catch blocks, it will simply terminate the method and throw an exception back to the calling method. In any case, the lines of logic between where the exception might be thrown and where the catch block is, that is where you should put any logic that's dependent on normal execution without an exception being thrown. That's the best place for that. Okay. I know this isn't very straightforward. It does take some practice. This is not currently a good way to handle the exception. Right now, we're just catching it and throwing it away. That's going to lead us to one of those situations where we have an application that is not performing as we wish. Okay, so exceptions, and I'm going to return back to our slides here. Exceptions, and a lot of the things I've talked about are here in the slides. What a throws clause is. A throws clause basically says this method may throw a checked exception. This method may throw a checked exception. So if we look at network DAO, we see a throws clause, which means if you call this method request, if you invoke this method called request, you're going to have to either catch or rethrow client protocol exception and IO exception. Network DAO. If we go back to online plant DAO, we see that it invokes network DAO request, and by contract, indeed it does handle a client protocol exception and an IO exception. It doesn't do anything with them yet. It doesn't handle it gracefully, but that's what we'll talk about in our next lecture. Okay. Catching exceptions. Again, we talked a little bit about this, but when we catch an exception, that's what we're doing here. That means if, in this case, a file not found happens, here's how I'm going to handle that. If a normal exception happens, here's how I'm going to handle that. So you'll notice in our example that we have 3 different catch blocks. So we can take alternate decisions based on whether it was a client protocol exception, an IO exception, or a JSON exception. We can, if we wish, take different behavior. On the other hand, each of these exception classes has a common ancestor, which is the class called just exception. Okay? An easier way to do this is we can say catch exception. We can just catch a general exception if we don't care the specifics about the exception, and then we can consolidate into one catch block. So an exception will be caught by the first catch block with a matching signature. An exception will be caught with the first catch block with a matching signature. So I think there's a little bit more information like the finally block here if this intrigues you for some reason and you want to read more about it. There's a little more information here on the finally block. But what I'm going to do next, we're going to go ahead, the video is about the 23-minute mark. I'm going to go ahead and wrap this up as a part 1 video. In part 2, we're going to look at some demonstrations of how exceptions happen and what the consequences are of catching or not catching an exception. So in this lecture, we looked at the 3 kinds of errors: syntax, logic, and runtime. And then we took a deeper look at exceptions. We know that with exceptions, we have 2 options. One is handle them locally if we can self-heal in some manner, like instead of using online data, use local data. Or if we cannot heal, raise a toast or some kind of message to the user. But if we're not in a UI layer, we might have to continue to throw back the exception until we hit a UI layer that can raise a toast. So that's a quick overview of exceptions. Join me for part 2 of this video when we'll look at some practical examples. Thank you.